In this lesson, we will be talking about colligative properties. Before I define this for you, I want to show you what ethylene glycol can do first. So from the video before, if you put ethylene glycol, this is ethylene glycol, or another name for this is antifreeze. If you put this in water, water will not freeze, or it will freeze if it's really, really cold, below 0 degrees Celsius, or it will also not boil until you get it a lot higher than 100 degrees Celsius, which means water normally is liquid from 0 degrees Celsius to 100 degrees Celsius. So if it won't boil, then you can have water at a higher temperature, and if it won't freeze, you can have water at a lower temperature. So the range that water can be liquid is a lot bigger. When I say it won't boil or it won't freeze, it will eventually boil or freeze, but at extreme temperatures. So let me tell you why that happens. So what happens is ethylene glycol bonds with water, and instead of it boiling, so this is water right here. So here's oxygen, hydrogen bonding with water. So instead of it boiling, it holds onto it. The same thing with freezing. The ethylene glycol prevents the water's molecules to attach to each other and freeze, so it won't freeze. So let me tell you what happens when it's trying to boil. So what we have here is water in this beaker. We have the intermolecular forces between water here, which is hydrogen bonding. And if we warm up the water at 100 degrees Celsius, you can break the intermolecular forces between the water molecules in the liquid, and it turns into water vapor right here in the gas. If the water vapor is at 1 atmosphere, and the atmospheric pressure is also at 1 atmosphere, those two are equal, then the water will boil. And the normal boiling point of water is 100 degrees Celsius at 1 atm. Okay, so here's the same picture right here. In case number 1, you have at 100 degrees Celsius, you have 1 atm of pressure pushing up from the water vapor, and 1 atm from the atmospheric pressure, and it boils. If there is a solute in there, so here it is, the yellow. Let's say the solute is Na+. It can also be Cl-. It can also be sugar. It can be ethylene glycol. Anything that you can dissolve in water is a solute. Okay. What happens here is that the water, here's the water molecule, will bond with the sodium or any solute. Just change the color here. This is called an ion dipole attraction, and prevent the water from boiling. So if you had sugar or salt or any solutes in there, ethylene glycol, let's say the temperature is 100 degrees Celsius, instead of having 1 atm of water vapor, you will not. You will only have, let's say, 0.5 atm. If you have 1 atm of atmospheric gases pushing down on it, do you think the water will boil? Absolutely not. The water cannot boil even though it's 100 degrees Celsius. So what you need to do is you need to warm it up. So instead of 100, let's increase the temperature to 105 degrees Celsius. Then perhaps at a higher temperature, more water will turn into the vapor phase, and maybe at it's now 0.7. It still won't boil, so heat it up some more. Let's say 107 degrees Celsius. Okay, you need the water to be hot enough so that you have 1 atm of atmospheric gases, of water vapor, to equalize the atmospheric gases, and finally it boils. So what happened here? Your boiling point is now higher, or the boiling point has been elevated. Elevated is another word for higher. Okay, so what happens is your boiling point got elevated. It's called boiling point elevation. So the boiling point goes up. And why is that? Because the salt, and it doesn't have to be a salt, it could be sugar, it could be solute that's dissolved in water, will interact with the water so it cannot boil. So what do? So you make it hotter. So it finally boils. Okay? Also, the salt or the solute that you put in there lowers the vapor pressure. Okay? So this is a colligative property. So you might wonder, what are colligative properties? Colligative properties are properties that depend only on the number of particles in there. So in this case, it doesn't matter if you put Na plus or Cl minus or sugar. It only matters how many particles you put in. The more particles you put in, the bigger the effect. Okay, so properties that depend only on the particles and not the substance. This boiling point elevation is a colligative property. Okay, because it doesn't matter what you put in there, the boiling point will still go up. Okay, another colligative property we'll be studying is freezing point depression. Now look at the words. Freezing point, depression is when you depress something, it goes down. So the freezing point goes down. Okay, let me tell you why that is. So here I have a water crystal, an ice crystal right here. So the way it forms is that this water molecule right here clicks into place and forms hydrogen bonds with this water molecule, and there's hydrogen bonding in between them. Here it is again. I drew it a little bit bigger here. There's hydrogen bonding in between, making a little hole right there, and it clicks into place and it freezes at 0 degrees Celsius. What happens if you put a solute in there? Let's say the solute is Na plus. It will get in the way right here. Therefore, this cannot freeze. The salt, or it doesn't have to be salt, again, it can be any solute that will bond with water. The salt breaks the hydrogen bonds of the water molecules, so the ice melts. It cannot freeze. So what do? If it cannot freeze, you're going to make it colder. Let's say it's now negative 2 degrees Celsius, and it still won't freeze. So make it even colder, negative 10 degrees Celsius, and finally it freezes into place. So the more salt you add, the bigger the effect. This is called freezing point depression because the freezing point goes down. Okay, so today you just learned 2 colligative properties. One of them is boiling point elevation, or the boiling point goes up when you add a solute or any substance in there that dissolves, and the freezing point goes down. Okay, so it doesn't matter what you put in. What matters is how many. That's very important. For example, if you put NaCl, NaCl breaks into Na plus and Cl minus. So how many pieces do you have? Well, you have 2 pieces. Therefore, if you put NaCl in there, it will double the effect because you have 2 pieces. If you have Ki in there, potassium iodide, K has a +1 charge, that's 1 piece. I has a -1 charge, that's another piece. You'll also have 2 pieces. If you put sodium phosphate in there, you have Na plus, 3 of those, Na plus. And you also have phosphate, PO4 -3. So how many pieces is that? 1, 2, 3, 4. 4 pieces. So sodium phosphate will quadruple the effect. Okay, so instead of a -10, it would be like -40 degrees Celsius. Imagine making water freeze at -40. Okay, also, you don't have to have a salt, you can also have a sugar in there. So let's say C12H22O11, that is table sugar. When you drop that in water, you only get 1 piece, C12H22O11, because it is a covalent compound. The bonds won't break, so they only get 1 piece. So you won't double the effect. You just have 1 effect from 1 piece. So again, colligative properties are properties that depend on the number of particles, not the type. So this will tell you how many pieces or how much effect it will give on the boiling point and the freezing point.